Hello, and welcome to the final part of our Frequency Trilogy series. Now, so far we've covered the lows and the mids, so let's end on a high note. Now, if you haven't seen our videos covering low-end and mid-range frequencies, I'd strongly recommend that you do, because today we're going to be building on the foundations, terminology, and concepts defined in said videos. Let's start with how we hear high-end, how it interacts with our rooms, our monitors, headphones, and then finally take steps to see if we can control or enhance the high-end in the context of music production. But before we get started, do you hear that? We've actually been running a 17 kilohertz sine wave behind my voice the whole time, and it might be the hardest tone to hear yet of the audio examples we've been putting in these videos. 17K sits at the very tip of the range of our human hearing, which again runs from around 20 to 20,000 hertz. So if you can't hear it, don't worry. In fact, the older we get, the harder it is to perceive things in that range. And to be honest, 17K doesn't always play a huge role in most of the mixes and masters that you'll encounter. And speaking of listening, please make sure you have a good pair of headphones or studio monitors fired up as we get deeper into this topic. When we talk about the highs, we're really talking about roughly 6K to 20K. Highs are mostly associated with sparkle, air, and sometimes clarity, even transient detail. But too much clarity can also be a bad thing. Too much high end can make your music sound brittle, tinny, strident, sibilant, or harsh. And remember from our mid-range video, our ears are really sensitive to stuff in the upper mids and highs. The more we boost the highs, the more loud our mix is perceived to be. And for better or for worse, we tend to think loud sounds better, which is honestly sometimes true. Louder can sound better, but if we add too much high end, you'll probably encounter issues like the ones I mentioned above. In fact, take a listen to this mix with overemphasized highs, and also take a look at what tonal balance control is showing you in that high-end region. Now, conversely, a deficiency in the high end can make your production sound distant, boring, lifeless, or even dark. Here's that mix again with too little high-end energy. The right balance between lows, mids, and importantly highs can lead to a polished mix that has the right sizzle, air, brilliance. Have a listen. So now that we know a little more about high-end, let's dig into the first chapter of this video, how we hear it. The human ear has a very interesting relationship with high-frequency content. Sounds that are higher in frequency tend to travel quickly as their wavelengths are shorter, and luckily for us mixing at home, they're more easily absorbed than low frequencies. More on that later. Low frequencies tend to wrap around and leapfrog over obstacles, which is why if you've ever been in line at a club, you can hear low end seemingly leaking from the club venue. And when that door opens to let someone through, all the highs come rushing out. When we're out in the world, high frequency sounds tend to be absorbed more by the air and obstacles in the environment, making them appear duller and less intense when they reach our ears. And this can influence our perception of distance because sounds with higher frequencies can sometimes seem closer than those with lower frequencies. This might all sound like stuffy audio engineering preamble, but the keen mix engineers out there could use this information to their advantage by intentionally playing with low and high frequencies in their productions to alter the localization and depth of mix elements depending on the kind of mood or vibe they're after. Producer Noah 40 Shabib exemplifies this to an extent in his early work, where you can hear much of the instrumentation being low-passed to make room for the all-important bright Drake vocal, putting the rapper close up to the listener while everything else folds into the scenery behind Drake. Another way high frequencies contribute to the sound of a production is in the transient detail of a musical event. Transient detail in audio refers to the brief, rapid changes in sound that occur at the beginning of a musical note or percussive event. These transients contain critical information about the initial attack and character of a sound source, and high frequencies play a crucial role in capturing and conveying these transient details. For example, if a drum is struck or a guitar string is plucked, the initial burst of sound contains high-frequency harmonics that give the sound its characteristic snap or pluck. In this first example, using Deconstruct in iZotope RX, I'm going to remove the transients and listen to how, when we snuff them out, we also get a loss of high end. I'll go before and after. After adding them back, we got back our punch and impact and a strong high-end presence. In a mixing context, achieving the right balance of transient detail often involves careful listening and adjustment. Engineers use their ears and reference tracks to guide their decisions during the mixing and mastering phases. Speaking of perception, some people don't take much notice of the highs in the world around them, or even the highs in music or spoken dialogue, while others happen to be extremely sensitive to audio events in that upper region, especially when something unexpected or unwelcome can be heard. Forgetting music for a moment, pops and clicks from a dehydrated mouth really throw people off. These clicks and smacks are concentrated in the upper regions of the spectrum, as shown here in iZotope RX. I've used a special feature to isolate only those clicks.
You can keep your space if it feels any better.
Now, I should add that mouth clicks aren't always a mistake that needs to be fixed. Again, the thoughtful engineer might leave them in, especially for a ballad or a stripped-down arrangement to give a sense of intimacy or vulnerability to the production, but those with severe misophonia might thoroughly disagree with that choice. The same thing is true of sibilants. These are strongly stressed consonants that occur when someone says a word with an S or ch, sh, or even a T sound. A microphone or even a naturally sibilant speaker can really distract from what it is they're saying or speaking when these high-frequency problems aren't dealt with.
Some days are easy, some days are tough. You're the only one to know when you've had enough. Some days are easy, some days are tough. You're the only one to know when you've had enough. You've got your reasons for giving up.
It's not just vocals. Instruments can suffer from an overabundance of high end as well. Cymbals, electric guitars, percussion even, can stick out from too much brightness, and it's our job as audio engineers to recognize these spectral pileups and solve them with the tools that we have at our disposal. More on that in the final chapter of this video. Now, I also should add that high-frequency content can be problematic even if it isn't strident or sour to the audiophiles out there. High-frequency content can mask low frequencies, making stuff down in the lower mids and lows less audible, which is a big problem if you're trying to emphasize musical elements or even just fundamental frequencies of certain instruments. And one more interesting thing about the highs, for those distortion junkies out there, did you know that high frequency content can be more prone to distortion and saturation effects? We'll talk more about that later on too. So now that we know a little more about how we hear high frequencies, let's recap before moving on to the role that high frequencies play in our mixing environment. High frequency tones may be challenging to hear as we age. High frequency content in music ranges from 6K to 20K. High frequencies contribute to qualities like sparkle, clarity, and transient detail. Overemphasizing high frequencies can lead to harshness and sibilance. High frequency content can influence our perception of distance and space in audio. Achieving the right balance of highs, mids, and lows is crucial for a polished mix. Now, everything that I said about loudspeaker and headphone design in those low and mids videos carries over to this video too, namely that professional studio monitors, whether 3-way or 2-way, will always accurately describe high end. And just as I mentioned in those previous videos, a set of studio quality 2-way monitors will be a much better choice than a commercial 3-way monitor. In pro audio, you often end up getting what you pay for. Going after an active over passive set of monitors will have little effect on their ability to accurately reproduce high frequency audio. But as I mentioned in the other vids, pairing the right amplifier to your passive monitors is really important, as the wrong pairing could have negative implications on the overall performance and sound quality. Now, one area that we should take a moment to talk about is the tweeter section of a studio monitor. The tweeter is a key component of a studio quality monitor, dedicated to reproducing high-frequency content with precision, accuracy, and minimal distortion. Its design and performance significantly impact the ability of engineers and producers to make informed decisions about high-end. Now, the tweeter's only job is to reproduce high-frequency sound waves, typically covering the range, but not always, from around 2K all the way up to the limit of human hearing. The tweeter works thanks to a crossover network, which divides the audio signal from your system into different frequency bands and then routes these high frequencies to the tweeter while directing lower frequencies to the woofer or mid-range driver. And for better or for worse, companies like to use all kinds of different materials and components to deliver the best possible high frequency sound in the tweeters. A quick word on the kinds of technology that you might see in tweeters on popular loudspeakers. Air motion transformers. AMTs use accordion-like motion in a strong magnetic field to efficiently generate high-frequency sound waves with precision, making them really ideal for high-quality, high-frequency reproduction. Soft dome tweeters. These are often made from materials like fabric or silk, and they reduce harshness and distortion while providing an even sound dispersion. You'll also see metal dome tweeters, some of which are inverted depending on the loudspeaker manufacturer. Ring radiator tweeters offer a really unique diaphragm shape and complex vibration modes, and they excel at high-frequency reproduction. They maintain controlled dispersion for clarity, making them favorable among audiophiles and professionals alike. That's a bit about the equipment. Now let's talk about how high-end behaves in an acoustic environment once it leaves those speakers and meets your space. Now, one of the nice things about high frequencies is that they're pretty easy to absorb and diffuse compared to low frequencies. Not a lot of material is needed to soak them up, but you will need to place at least a few panels fixed at perhaps the first reflection points in your room to catch any buildup before it gets out of control. A first reflection point in acoustics refers to the location in a room where sound waves from a sound source, like your monitors, bounce off a surface, typically a wall, and reach the listener's ears shortly after the direct sound, potentially affecting the perceived sound quality and even the spatial characteristics of the audio playing back in the room. In the low-end video, we talked about room modes, which are essentially a feedback loop of frequencies that fire off from the speakers and then meet themselves, eventually amplifying or sometimes even attenuating. However, when we talk about high frequency buildup, we're often dealing with flutter echoes. Now, flutter echoes occur from reflections of mid and high frequency sound waves that are bouncing back and forth between two parallel reflective surfaces. You can hear these echoes in small rooms that are devoid of any acoustic treatment by just clapping your hands and listening back for a kind of metallic reverberation. In fact, stairwells in commercial buildings are another great place to try this clap exercise if you really want to hear them. Now, the trouble comes when flutter echo is introduced to percussive instruments, like, say, a snare drum. It imparts a weird delay, which alters the tonal quality and introduces a metallic reverberation. So suffice to say that absorbers are best suited to control this challenge. Here's some more things to think about when setting up a critical listening environment as far as the highs are concerned. When sitting in the listening position, it's so critical to make sure that you're set up to hear high-frequency content well. So first, make sure you're observing the equilateral triangle rule. This means making sure that the monitors are positioned at an equal distance between all vertices, so the two speakers and the focal point, which is usually you, the listener. But in addition to this, you'll want to make sure that your ears are in the right position vis-a-vis the tweeters. It might surprise you to learn that high frequencies are actually very directional, especially stuff in the really high range from 15 to 20K. So going back to our tweeters, it's important that the ear is aligned with the position of that tweeter so that the frequencies can be heard and then mixed accordingly. So if your monitors are positioned vertically, make sure that you're sitting with your ears aligned with the height of those tweeters. And if your monitors are positioned horizontally, make sure to raise them up so that the tweeters still meet your ear. If the ear is not aligned, you're not going to have a complete picture of what's coming out of the high end of your studio monitors. You can experiment with this by playing with a 17 kilohertz tone from RX using the noise generator. Take a listen as you raise and lower your head from perfect alignment with the tweeters. You'll be very surprised at what you hear and don't hear as your head moves around. Okay, let's summarize before moving on to the final section. Tweeters, responsible for reproducing high-frequency content around 2K and above, significantly influence monitor precision and sound quality. Tweeters come in various designs and materials, including air motion transformers, soft dome tweeters, metal dome tweeters, and ring radiator tweeters, which each offer unique characteristics. High frequencies are relatively easy to absorb and diffuse compared to low frequencies in acoustic spaces. Addressing first reflection points and flutter echoes is crucial for accurate high-frequency monitoring. Properly aligning your listening position with the height and position of the tweeters is crucial for high-frequency perception, ensuring a complete and detailed audio picture while adhering to the equilateral triangle rule for monitor placement. So now that you have a grasp on specifically what high frequencies are, how your brain decodes them, and how they behave in your studio, it's time to turn now to how they show up in your productions and what you can do to control or enhance them. And the very first place that I want to start is by talking about some popular processing types and their effect on high end. EQ, compression, time-based effects, and saturation. Each one plays an interesting role in shaping the highs. Once we cover each in detail, we'll finish by diving into popular mix elements like guitars, vocals, and more, and discuss some magic, high-end frequencies that you'll definitely want to know about. As we mentioned early on in this video, saturation can affect mid to high frequency content more than most other creative processing. Saturation in music production refers to the distortion or coloration of audio signals, typically achieved by driving analog or digital audio processing equipment to its limits. It can introduce harmonics, add warmth, or create a vintage analog sound. Now, while saturation can be a valuable tool, it does have a tendency to affect high frequencies more than others. So for example, I'm using Ozone 11's Exciter module on a clean electric guitar track, and I'm pushing the amount and mix all the way up. The gray filled-in section represents the original signal, and the white trace represents the signal after it's been introduced to saturation. Notice that from 3 to 20K, the processing is creating new spectral content, specifically along the upper mids and high end. We can use the new Delta feature to really hear where the saturation is being focused. The Delta button will essentially perform a null test so that we can hear the difference between the processed and unprocessed signal. Have a listen and take a look. So now you know that saturation can create additional spectral content specifically in the high end. This could be desirable or undesirable depending on your mix goals, but it's really interesting to know what implications saturation can have on your mix elements. So use this knowledge to your advantage, not just on guitar, but drums, vocals, and more. But just remember, us humans are really sensitive to mid and high frequencies, and we might think our saturation sounds better because those extra harmonics have led to a louder overall sound. Make sure to use tools like Gain Match in Ozone and other iZotope products so you don't get fooled by the louder equals better phenomenon. Compression has played a really interesting role in this series so far. In the first video of the series, we explored how sidechain detection circuits influence the compressor's impact on the low end. But it's important to note that compression also significantly shapes high frequencies. When configuring a compressor, it's really important to grasp that your choice of attack and release times have a notable impact on the high frequency elements of the signal passing through it, with fast attack times potentially attenuating transients and, as illustrated in the drum example, affecting the high-end presence. Now listen to the difference between an attack time of 20 milliseconds, very fast, and 500 milliseconds, the slowest attack time possible, in Neutron 4's component compressor. With a really fast attack time, the compressor is rushing to tamp down on the transient energy, which affects the highs, as I noted at the beginning of this video with that drum example. And this doesn't just have implications at an individual track level. Consider how compression at the mix bus or mastering stage can play a role in shaping the high-end profile of the mix at large. That's the first way that compressors affect high-end. The second way is perhaps a bit more obvious. Compression can make quiet, high-frequency stuff louder. Be aware that any tracks containing high-end hiss, like amplifier noise, electrical buzz, will be impacted by compression. Most compressors push quiet and loud sounds closer together to bring consistency to the dynamic range of the performance. So an audio track that has a lot of high-end unwanted noise that isn't tonal will be pushed up against the glass, so to speak, and made more obvious to the listener. So cleaning up unwanted noise with a tool like iZotope RX is critical to prevent high-end buildup when compression enters the picture. In the Your Ears section, we discussed de-essing strong sibilant events in a musical recording, tackling those S sounds. That's done with a de-esser, which is essentially a compression tool that's designed specifically to control sibilants. You'll find de-essers in iZotope Nectar and RX, and you'll find sibilants typically falls between 3K and 12K. Here's some before and afters.
Some days are easy, some days are tough. You're the only one to know when you've had enough. You've got your reasons for giving up. It's the same old situation. Some days are easy, some days are tough. You're the only one to know when you've had enough. You've got your reasons for giving up. It's the same old situation with your dumb.
Now, de-essers shouldn't be limited to sung or spoken vocals. They can also be employed to control excessive high frequencies in sources like electric guitars, cymbals, and more. Once you develop the ability to identify harsh frequencies, you'll notice them in various non-vocal tracks as well. Now, time-based effects like reverb and delay also have implications for the overall high-frequency composition of a mix. Think of time-based effects like an ambience generator, elongating and expanding the sounds already present in a mix. When a sound like the splash of a cymbal or the crack of a snare occurs, it's momentary. It comes and it goes. When you add an ambience generator like reverb or delay to that cymbal or snare, you allow all the characteristics of it to persist long after the sound was originally triggered, effectively sustaining it. Those sounds are inherently sibilant, and the introduction of those effects can really grate on the listener as the strident high frequencies are prolonged, effectively maximized by the reverb and delay. This is why it's so important to use an EQ to disinvite some of those frequencies from the reverb party. Take a listen to this example. I'll play it without any EQ first.
In my mind, I swear there's colors in my mind. At the dive, they're playing Bowie for a dime.
Now, using an EQ built into Neoverb, I'll low pass the signal to prevent much of the 5 to 20K range from being influenced from the reverb. I'm also going to filter out some of the lows to keep the reverb from muddying up the sound too.
In my mind, I swear there's colors in my mind. At the dive, they're playing Bowie for a dime.
It's pretty impressive how much of the sound was tamed with that curve, especially the high end. Now, I've saved EQ for the final part of this video because, in my opinion, EQ plays the most direct and consequential role in controlling and enhancing high frequencies. Remember a tip from our last video: you can't add frequency content with an EQ where there is none. For instance, boosting the highs on a kick drum track above, say, 10K won't do much because you'll just end up with more hiss. There's not much up there to begin with, so concentrate on adding airy brightness to instruments that already have some high frequency vibes like vocals, overheads, even snares, cymbals, hi-hats, guitars, and more. Let's go over some of those instruments that I mentioned and show how careful enhancement of the high end can get you really interesting sonic results that you might want to try out in your next production. The high frequencies in vocals are where you find clarity and air. Certainly in today's pop music landscape, bright, airy vocals continue to be in vogue, so let's add some air to vocals now. Remember, before you start boosting with an EQ, it's so important to tamp down on sibilance, mouth clicks, any other high-end stuff that might be further exacerbated by our EQ brightening move.
I swear there's colors in my mind. At the dive, they're playing Bowie for a dime. Morning bloom, she walks out to get the news. By the afternoon, we're waltzing in the other room.
Notice how in the after we get a bit more clarity and sheen from the vocal without sounding brittle or harsh. It's really important when you're making your EQ moves to have an idea of what you want to do and then toe the line between enhancing and introducing sourness, especially in the top end, especially on a track element as important as vocals. Now, there's two common approaches to EQing electric guitars, but one tends to be more effective, which involves applying a low-pass filter. In the previous example, we focused on boosting high frequencies. It's really important to note that distorted guitars can occupy a lot of the frequency spectrum, and if left uncontrolled, they can encroach on territory that's typically reserved for hi-hats and cymbals. As a result, I'd recommend experimenting with a cautious reduction of frequencies above 6 or 7K within the context of the mix. Now keep in mind that guitars are super sensitive to EQ adjustments, so exercise care when making changes in that area. Hi-hats are a constant presence in a mix, unlike cymbals which come and go periodically. Alongside vocals and hand percussion, hi-hats and how you treat them have a significant effect on your mix's overall high-frequency character. It's really critical to avoid excessive boosting in the high end on hi-hats, as the listener's ears can become fatigued really quickly. To enhance the crispiness of hi-hats, consider an EQ in the 5 to 12K range. Boosting here will impart a glimmering, shimmering quality.
I think we've reached impending doom, and if the lies are true, we might as well be in a tomb.
Again, that was a lot. Let's recap. Popular processing methods like EQ, compression, time-based effects, and saturation play a really significant role in shaping high frequencies. Saturation can affect mid to high frequencies more than other frequencies, so be very careful as you add distortion and loudness. Compression, particularly attack and release times, can influence high-frequency content by affecting the transients. De-essers are designed to control sibilance and can be used on vocals, but also guitars, cymbals, and more. And time-based effects like delay and reverb can sustain high frequencies, maximizing them. And an EQ should be used to shape the effect's influence. EQ plays a direct and very consequential role in controlling or enhancing high frequencies, and careful adjustment of high frequencies can add air, brilliance, and sparkle to instruments like vocals, acoustic guitars, and so much more. And that about does it for the series. Hopefully you learned something new and maybe remembered a couple things that you forgot about low, mid, and high frequency treatment. I hope the series was genuinely helpful, and now you feel armed with knowledge for your next mixing challenge. Please visit us at iZotope.com to learn more about the tools and topics that we discussed here. And as ever, I'll see you in the next one. Bye.